Okay, so we've got a velocity time graph again here, and part A is only worth 1 mark. Okay, so we shouldn't have that much work to do. And quite simply it says write down the gradient of the curve when t is 4.6. So if I go to 4.6, okay, you can see, well, 5 is going to be there, so that's where 4.6 is. If you look at the curve there, 4.6, it's actually quite flat, isn't it? If you notice, it's very flat. You know, if I was to put my ruler against it there to sort of imitate the direction, it would be perfectly flat, isn't it? If it's flat, that means the gradient is going to be 0, okay? Because remember, gradient measures how steep something is. Well, if it's flat, it's not steep at all, okay? So the gradient will be 0 there, okay? In effect, remember we looked at the gradient measuring the acceleration, so because the gradient is 0 there, it's not actually accelerating at that point, okay? So it's staying sort of at that constant velocity, staying at the same speed for a small period of time there. So part B then says find an estimate for the acceleration of the object at 3.5. Now again, you see that word estimate, okay? And to get the acceleration, we're going to draw a tangent again, and it's going to be an estimate because we are drawing a tangent by I. And it's going to be at 3.5 seconds. So 3 is there, 3.5 is between 3 and 4. So we're going to go at that particular point there. What's quite nice about it as well is that it's a nice sort of gradual climb here. It's going to be easy to get a ruler lined up here with this. Okay, so at 3.5, that's the point there. So I need my tangent to touch at that particular point, the graph. Don't want it to go through it. So there you go, it touches the curve at 3.5, okay, between 3 and 4. So I've got my tangent. I then need to pick 2 points on that tangent, which are nice 2 points. Okay, so that point there is particularly good, okay, because when t is 2 and when the velocity is 23. And what else should I go for? It's not that obvious here, isn't it? We'll go for this one here, I think. Okay, that's quite nice that it goes through that point there. So that will be 6.2 and the velocity will be 36. So I'm going to draw my triangle. So I'm going to go up and then across. So we've got to look at now how much we've gone up. Well, we've gone up from 23 on the axis here, all the way up to here, which is 36. Okay, so that difference is 13. It's a climb, it's a rise of 13, and then we've gone across from 2 to 6.2. It was, wasn't it? Yeah, because 1 square represents 0.2, so that's going across 4.2. So to get then the acceleration, essentially it's the gradient value, which is the rise divided by the step. So the rise is 13 and the step is 4.2. Okay, so we do that on our calculator. So when I do that, I get 3.1 to 1 decimal place. Okay. Units, again, look at the units they've used for velocity. Now this time it's actually meters per minute. Okay, I think that's what that is. They're meters per minute. Okay. So with regards to the acceleration, if it's meters per minute for velocity, it's going to be meters per minute squared for acceleration. They don't ask for the units, there's no need to worry about it, but that's what you always do. You take those units there and you just put a squared on the, in this case, the minutes.